and has radius 0.815 mm. Calculate the drift velocity of the electron in such a wire carrying current 1 ampere, assuming free electrons per atom. Come on, try this. Read this question, give a thought of it. Try just thinking. It's okay if you get or not. Just try first thing. Try this one. Yes, girls. What happened? Have you tried? You understood? What we have to do? Shall we see how to solve? I want to try. Pravalika, Renuka. Yes, what's the answer? Renuka, Pravalika. Or shall I solve here?
Yes, sir.
Okay. Fine. Let's see what is given here. We have radius, this much. Current is 1 ampere. Okay. So we need drift velocity, VD. Okay. So finding VD, we need numbers, number of electrons, number of materials. So we have here this formula. Q equals Q by T equals to Q and A V D. I equals to Q and A V D, which is drift velocity's formula. VD equals to I by Q and A. So we are finding I equals to Q and A VD. So here N is the number of densities of copper atom. Na is the number of density of copper atom, because here we have copper atom. Okay. So VD equals to I by NaQ. And I by A is J. So J by NQ. V equals to J by NQ. Drift velocity VD and V is the potential difference. So we have 1 free electrons per atom. So that means N number of electron equals to number of Na, means density of copper atom. That's what it means, like number of 1 free electrons per atom. That means total number of density will be equals to number of electrons. So to find density of this one, we have for density of copper, we have 8.93. Actually in question it will be given. And M is molecular mass. Moles, 63.5 grams per mole for copper. These two values are for copper. So Na equals to rho N by M, mass and density, grams per mole. So we can find this Na value. Now Q equals to E, as we have 1 electron, so Q equals to Ne. So N equals to 1, that means Q equals to E. And area we need. A is pi r square. So Na Q as E, A as pi r square. So we can find VD by substituting all this value. I, what was I here? 1 ampere. I is 1 ampere. Na we found just now 8.46. E we know. What's the value of E? What's E value? Do you know what is E value? What shall I write here? Pravalika. Renuka. What is E value?
So 1.6 into 10 power minus 19.
Yes, 1.6 into 10 to the power minus 19. Which is 1.6 into 10 to the power minus 19. For actually it is minus for electrons. But for protons it will be plus.
Okay, sir.
And for alpha particles equals to 2e. There's few things we need to remember. Okay. Alpha particles equals to 2e. In sometimes they will give instead of electrons, they will say alpha particles. That means 2e. Come on. Substitute values and calculate. Then let's check. Are we getting same answer? Yes, what's the answer? Shall I scroll for the answer? Did you try multiplying? Renuka, Kavalika? Oh yeah, somebody got an answer. Oh, you're not able to understand. See, what we did here. We need to find their drift velocity. This is our formula. For that, we need to find Q, we need to A, we need N also. And I we have. We need all these things. A we can find out by area, pi r square. And we need to find out, right, numbers. So how we are finding here with this one, with the help of this one. And A equals to, and A is what? Density of copper molecule. This is the relation between, see, the relation between mass density of copper, molecular mass, and Avogadro's number. So this Avogadro number for this one, that is 63.5 gram per mole. And yeah, not this one, sorry, this is molecular mass, and is your Avogadro number, 6.02 into 10 to the power 23. This is your Avogadro number N. So what we are doing here, Na equals to rho, that is density into N Avogadro number by molecular mass. Molecular mass of which atom? Copper. Density of copper atom. So with the help of this relation we are finding Na value. Na equals to N. That's what we already proved here. We already said here. Because it is for one atom. That means Na will be total number. N will be the total number of density atom. So Na we are getting 8.46 approximate, whatever value it is yours. You check yours. Atoms per meter cube. And we are substituting this value in this equation. So what we'll get here? Na is 8.46 into 10 to the power 28. See, everything converted into meters, SI units. 1.6 into 10 to the power minus 19. This value. Pi is 3.14. Area 815 mm. That means 0.000815. Or if you find difficult this one, so you can use here like this also. 815 into 10 to the power minus 6 meters. This is also okay. We can use this instead of this one. We can use 815 into 10 to the power minus 6, the whole square. So 815 into 815 into power minus 12. Understood? Calculate and check. Are we getting the same values? Yes, guys. Are you able to solve? Pravalika, you got this answer? Renuka?
Yes, sir.
Okay. What about Pravalika? Shall we go for next question? I think so. Her mic is not working. You said anything? I can't understand. Like, did you say anything, Pravalika?
Sir, sorry.
You got the answer? It's gonna ask.
Yes, sir.
Okay. So, okay. Let me see. Can you solve this one in like less than 30 seconds? Now let me check. But did I give that question? No, not here. Okay, I didn't give. Okay. This is easy, but I want you to solve less than 30 seconds. So let me write the question. If the charge through a conductor is given by Q equals to 1.5. Okay, I write here. Q equals to 1.5 T square plus T. Current caused in T equals to 2 seconds will be what? Solve it. I want this answer in 30 seconds. Come on, quick. The time starts. Where's my clock? Sixteen, 15, 14, 13, 10. Okay, yeah, time up. Did you finish solving? 72. Acha. What is your answer, Pravalika? Are you there? Pravalika?
Yes,
Yeah. Are you solving?
yes, sir. So should we substitute value in
Yes, we have to substitute value of t. Don't take so much time. It's just easy question. We need to finish this question in 30 seconds. Let me try. Let me keep a timer first. Seven. Yes. Just completed in 30 seconds. So we should do faster because we are giving competitive exams. So as fast we will save time for some difficult question. That's why I'm giving you timer. Yeah, by the way, were you able to hear the timer? It was clicking. I don't think so, right? It was audible, the system audio.
yes, sir.
Okay. Okay. Yeah, units. This question will solve. In hydrogen atom. Okay, by the way, have we done this one? Let's see. No problem. Electrons moves in an orbit of radius 5 into 10 to power minus 11 meter. The speed of 2.2 into 10 to power 6 meter per second. Okay, it's very high speed. The equivalent current will be. So there are options also, but I'm not giving any option. If you want, I can give. Okay, what do you think of this question? Any idea? Yes. What's the answer? Jafar? Pravalika, did you try it? Renuka, what about you? Okay, then let me give you a hint if you're not able to solve. Okay. Now, first one, what this says, electron moves in an orbit of this much radius, speed this much. I want current. Relation between speed and current we have. We'll find that. So first of all, what is given here? Let's write given terms. Radius equals to 5 into 10 to power minus 11 meters. Speed equals to 2.2 speed. They didn't mention here drift speed or whatever speed. So let's just write here speed. We'll see that later. So let's find out first frequency. Okay, we find frequency, then we'll do time period. Okay, if we do that, I equals to Q by T. Q we can find NE. Yes, we can find with this one. Okay, let's go one by one. First, frequency equals to 1 by time period. Okay, so time period equals to 2 pi r by speed, velocity. So which is 2 pi into r is 5 into 10 to power minus 11 divided by v. But let's not divide here. Keep it like that. Let it be like that. Let's not divide here. Anyhow, we don't want t. We don't want t here. 1 by t. So it will be reverse. So it will be v by 2 pi r, which is 2.2 into 10 to power 6 by 2 into 3.14 into 5 into 10 to power minus 11. So 2 means 11, and if you multiply 3.14, what are we getting? Check. You just multiply and tell me. Till then, I'll just proceed the question. Okay. I need Q. Q is charge. Here time period we take for, time period is for 1 revolution. Charge in 1 revolution into total number of revolution in 1 second. So that means we'll find this revolution here. And there is charge, it is 1.6 into 10 to power minus 19 into this value. And if you find Q, that will be the answer. I equals to Q by T. T is 1 second. So whatever we get this answer, it will be I value, ampere. Okay, what are the values? What are the, tell me, multiply and tell me, what are the values? Charge, number of revolution in 1 second. So we need this frequency. That is F. That is E. E into F. Okay. Yeah, anyone calculated? Tell me the values. So I will write here. No one did? Mohammed Jafar, Pravalika, Renuka, anyone calculated? Give me the answer. This will be per second, whatever value you will get here. This is charge coulomb. And that will be your ampere. Frequency is what? Cycles per second. No one did the calculation? Pravalika, have you done the calculation part? Can you hear me? You guys can hear me, right? Okay. Not done calculation? Okay. Do it and tell me answer fast so that we can do the next question. By the way, you understood the question, right? How we started, how we did, what we need. See, always go with like that. So what we need? Current. So what is the relation between the given terms? Find the relation. You want me to calculate? Okay. Means 0.1. Okay. 11 will go up, it will become 16. So if we go with one decimal, 7 into 10 to power 15. One 72 is 42. 10 to power minus 3. 1.12 into 10 to power minus 3 coulomb. That is, answer is 1.12 milliampere. This is your final answer. Are you getting this? Did you get this answer? Yes or no? What happened? Are you able to solve or not? Okay. Jafar, you're not sending your answer in your chat box? What about Pravalika? Did you get the answer?
Yes.
Okay. Okay, this is also easy question. I'm answering. Few seconds, 30 seconds. The number of electron passing through a heater in 1 minute. If current, if it carries current of 8 ampere. If it carries current of 8 ampere. Will be, okay, the timer starts now. 30 seconds. Come on, send me your answers. Time up. 30 seconds over. Who has completed? Renuka, Pravalika, Jafar. taking so much time? Okay, then let me solve. It's very easy. N equals to IT by E. How we got this? Q equals to NE. I equals to Q by T equals to NE by T. With this, we are finding N value. 8 into 60 seconds divided by 1.6 into 10 to the power minus 19. 16 and 6. Just 3 into 60, 30. 5 is 30. Correct. Into 10 to the power 19. If you go up, it will be 1. And this one more 0, that is 21. 3 to the power 21. Did you get this answer? Let's speak up. Why you're sleeping? Guys are there or sleepy? Pravalika, are you there?
Yes, sir.
You're feeling sleepy?
No, sir.
Okay. What about Renuka? Are you
Sir,
there?
I am also there.
Okay. Fine. So I guess both of you got this answer. What about Jafar? Are you there? Mr. Jafar? Okay. Started solving, right, Jafar? Good. Okay. See, before we end the class, let's do one more question. We have time. Now, question is here. The copper we did already, no? Okay. This one we already did. A conductor of non-uniform cross-section area non-uniform cross-sectional area has sectional area at 3 points. A1 equals to 2 centimeter square. A2 equals to 4 centimeter square. A3 equals to 6 centimeter square. If the current of 5 ampere is passed through A1 the current will be give values when passed through A2 and A3 respectively. So what is the question here? Find the current that will pass through the given value when it is passing at A2 and A3. We need to find current. So option I'll give you here. 10A, 15A, B, 20A, 30A, C, 2.5A, 1.66A, D, 5A, 5A. Take this question as a homework. Try it, think it, and we'll discuss tomorrow. Tell me answer tomorrow. Think and solve. Take your time for solving. Once you finish writing question, tell me. I'll stop sharing.